Here we go. We have a question in order traversal. So you have given a binary tree and your task is to return its in order traversal. So what do we mean by in order traversal? An in order traversal first visit the left children's means the left subtree, then the root itself means that the node itself, then we finally visit the right child. It means the entire right subtree. So we have given this tree in a tree format. So we have given only root node and we need to return a list and list. So we have given this input, this is the expected output. For this is the expected output. So now let's build the approach. How we gonna approach this question? So we need to find in order traversal. Yes, we need to find in order traversal. It means first we visit left, then node, then right subtree. So we have given the root node. So first what we'll do, we will call the left subtree, then it will call the left subtree. So its left is null, so we will include the node. So we will include it into our answer list. Then we visit its right side. So we are on to 7. Its left is null, then the node itself. So we got 7, then the right side. Then we visit left side, it is null, then we visit node. So we have 10, then right. So its right is null. So we are again back into 7. So we have traversed all 3 sides, means all 3 steps we have already considered. For 1 also, then it's time for 8. So we have visited left, so we have visited left. Now it's time for node, so we will include node. Then we visit right side. So we are on to 5. It's left, then 6th left is null, then we include the node, then we will traverse the right subtree. So right is null, then we are again back on to 10, so we will include 10. So this is a recursive function. So let me write the recursive function here. We have solve. I am first passing node, so it will take an argument as node. Then we call the solve function again. Let me write it here. So we will call the left subtree, means node left. So node left is a subtree. First we call this, then we include the node. So answer dot add node value. So we will include node value or node data. Then we will traverse its right side, node right. But we have missed one thing, which is the most crucial thing in the recursion. It means our base case. So if our node is null, we cannot visit its left side, we cannot add, we cannot visit its right side. So we will directly return back. So let's continue. We are on to 10, we have included 10. It is time to traverse the right side. Right side is null. Again come back to 5. So 5 left side we have done, then 5 node, then 5 right. So it's left, it's node, so we'll include the node, then it's a right. So we have completed the tree traversal in order. So we'll again, so from 6 we come back to 5, from 5 we come back to 8. So from 8 we will just return our answer list. Let's code this. So we need to return an list. So let me create a global list. You can also create the list inside a function, but then we have to pass in the function also, in the recursive function also. So I am not a big fan of passing list into the recursive function, so that's why I have taken global list. So it will return me void. We have solve function, it takes a node. If our node is null, directly return first. This is the base case. So in the in order traversal, so let me change the function name. In order, uh, in order, yeah, let's write solve only. So we first need to visit the left children. So call for the left side, then include this node. So answer dot add node data, then visit the right child. Let's run this code. I hope it will work, and let's submit this. In between, let's talk about time and space complexity. So we are traversing a node only once, so its time complexity is order of n. What about space complexity? So we are creating a list. This is the expected return type. So this will contain all the nodes data. So it will be order of n plus the recursive stack space. So it will be order of h. Let's find out. And we have met the expected time and space, but the space is constant. I think they are not considering the recursive stack space, and also they are not considering this answer list. One thing I want to mention, in the in-order traversal, you can also use this stack data structure. Here I am using recursive stack, so you can also use a stack data structure. And there is one another way which I think you should know is Morris order traversal. So in this I'm not gonna teach Morris order. I'm just making this video so for beginners. So it will just take a simple recursive function, and that's all, nothing more than that. And thank you all for watching this video.